First gen, by far the most efficient one, and followed by thin film. That's purely experimental. It is not as efficient as the first generation. And the non-silicon one, which is the third gen. This is not out in the market yet, so it's still in the experimental phase. So this is the one which you see almost everywhere. So the silicon wafer, you can break it down into two different types. One is the monocrystalline, which you can see from that black patches over there. Then another one will be the polycrystalline, which you can see from here. It's basically one panel like that. Right, so monocrystalline and polycrystalline. This is the one which is on our roof, which produces the main bulk of our electricity used in the building. Okay, so there is another one, which is a mixture of the first generation and second generation, known as the HIT panel. So how that works is that it produces electricity, but it's bifacial, meaning that you can produce electricity both from light coming from the top and from reflected light coming from the bottom. So this makes it more efficient as compared to the first generation. Of course, it's also much more expensive, about 20% more expensive. That's why we can't put it on the main bulk of the roof. Right, so but all in all, efficiency is really just a number. The main thing when it comes to the optimal performance of solar panels would be the direction it's placed at, and also the angle it's placed at. So ideally, I believe ideally it would be better to put the solar panel flat, but it will cause a lot of problems when it comes to maintenance, especially when it rains, or when, let's say, a bird dies there. It really affects the performance of the solar panel.
So you're like clear.
Correct. So over here, what we do on the roof is that we place every solar panel at an angle, a tilted angle, so that it's kind of like self-cleaning. So especially when it rains, and Singapore does rain a lot, if there are any leaves or any birds which die there, the angle plus the rainwater usually is able to clear it away. Yeah. Right. So all our solar panels is okay in a normal solar panel system. The solar panels, the amount is always connected to just one converter. But over here, what we do is that the same amount of solar panels, we break it down into a grid pattern. So let's say break it down into a 9x9 or whatever system you're doing. So basically break it down into a grid pattern, and then each square on the grid is connected to one converter. So why we do this is that it's easier for us to track which solar panel is not performing as optimally as you want it to be. Then instead of testing the whole panel system, you just need to test the one which is not performing as well. So it could be a bird died there, or there's a accumulation of leaves over there. But most of the time, if there really is a problem, it's probably because of faulty solar panels. Okay? Right, so the amount of electricity we produce, I don't know if this is still updated, but at that point of time when we first made this poster, there was enough energy to provide for 45 4-room HDB flats for a year. So 4-room HDB flats, if you talk about one block, it should be about at least 20 floors. Right. So but the problem with this is that because we have the amount of roof space, which is a lot. But if it's a HDB flat, the roof space is very small. So you can't really produce this kind of figures for a normal HDB flat if you actually put it on a HDB estate. Okay? Yeah, so that's the main problem with solar panel so far. It's too expensive, and then it's not able to work that well, especially with small confined spaces like ours. So people might ask why don't we just put it on the sides of the building? When you put it at 90 degrees on the side of the building, it really cuts down on the optimal performance of the solar panels. Right, so there's something we have to work with. So now most of the solar panels are just used to, it's just used to power the lights, the corridor lights at night. Yeah. Right, so any questions for me so far?